Hey guys, how's everything going? This is JSer. In this video, let's solve another problem from LeetCode. It's 923 threesome with multiplicity. Multiplicity. Given an integer array and an integer target, return a number of tuples I, j, k such that the sum of them equals to the target. As the answer can be very large, return it modulo this. Okay, so we have an array like this. We have the target, and then we have 620 tuples, which sums up to 8. Well, I think we have a simpler version of this problem, right? So we means two sum with, if we have a going to do two sum, like oh, these are the numbers. If we're going to get all the permutation, get all the possibilities of the combinations of two sum, it will actually cost us quadratic times, right? Quadratic, because they are kind of pairs and we compare to the target. So this is our time complexity. But actually, we could do a little caching. Meaning while we are checking, we're checking the sum of two numbers. Why don't we just fix a number and check if there is another number of the difference between the number and with the target. So if we pick this number, we could get the desirable number, and we could just check if it is there or not, right? So this becomes probably we use a set. We could say we use a set to hold not set. Ooh, yeah, there might be duplicates. Let's first think about no duplicates. Okay, no duplicates. Then use a set to hold the numbers, hold all the numbers, and loop through each. This is linear time, and for each, we just check the set has target subtracted with this number, right? So this is actually constant time. So we've improved from quadratic time to the linear time plus linear space, right? If there's duplicates, it's simple actually. We could for duplicates, we just use a mapped, right? Use a mapped, which is a number and the occurrence. So while we just find it and just sum the occurrence up, and just sum the occurrence up. Is there a duplicate? Wait a minute. If we choose a number here, yeah, oh yeah, we need to choose loop through set, yeah, and add elements to the set. No problem. So this is it. We fixed the last number and check with the set, so we improve the performance. Now let's consider threesome case. Well, we could do the same actually. I think we need to fix the last number. If the fixed last number is 2, then the problem becomes the two sum in here, right? Yeah, so if we fix the last number, it becomes linear time to loop through the last number and problem of two sum. So finally, we could we could improve the time from cubic to quadratic, obviously, right? Yeah. So has it? Okay. Okay, so how should we do it? Well, we choose the last number, and for each round of the loop, we would do two sum. Do two sum for the second. So the second number, right? Okay. So let's do it. We create a function called toSum, and this toSum actually has a start index for a subset of the array, right? And so it's the start of the index actually will always start from 0. So we choose the length. Okay, and the length of the array and the target. Start from 0. Okay, end index. Okay, which is the end index. Yeah, if n is smaller than I would say at least 2 items, right? At least 2. So if it is smaller than 2, just return 0. There's no tuples. Yeah, and then we for let I equal 0, I smaller than and I plus plus. As we analyzed here, we need a map to hold the occurrence. So this is visited. No. Occurrence new map. While we're looping through it, okay, we actually put the first number in, which is ARR new map ARR 0 and 1. Okay, and I start from 1, the next number. Occurrence says. Okay, now we just check if has the target, right? Has the target difference. So if let's say current would be ARR I, the difference would be the target subtracted with this current. So if occurrence has the target subtracted with current, okay, I'll catch the difference. Diff this one, diff. If it has it, we just accumulated the result, right? So let result equal 0. Result will be plus with get the diff. So we get this kind of tuples, right? Yeah, if there isn't, we do nothing and go to the next number, right? But while we go to the next number, we need to push this current number in. So if occurrences has current, occurrences set current, occurrences get current incremented by 1. If not, then we set it with set current with 1. So this is it. This is the occurrence set, and while this is done, we just garbage collect this set on the map, the problem, and then finally we could return the result. This gives us these two sum actually cost us a linear space plus linear time. Great. Now this is for two sum by the end and a target. So now we are doing the 3 sum. Okay, we for yeah, we would for let I equals 2. Okay, if the length, we just filter out if it is not enough, say it's less than 3, just return 0, right? Okay, so we okay, let result equals 0, And also we have this maximum modulo this. And then we start with 3, and I would smaller than the, and then loop through each item, fix the last number, right? And now we would just get how many the combination of the tuples with the target subtract with the current number, right? It doesn't say that the integer. Okay, the integers are all target is positive. This is positive, so actually we could improvement it if the target is if the target is it could be 0. So if target is smaller than 0, we return 0. Great. We loop through it, so we just the result would be plus with the 2-sum end at I -1, right? With the previous subarray and the target negative with ARI. So this is it. And we don't forget to module it. So modulo. Oh, this result actually might be overflowing. Okay, let's do this. Result plus this, and then modulo. Oh, it should be this. And then we return the result. Let's run the code. Invalid unexpected token. Const 2-sum. What's the problem? Oh, yeah, I'm sorry. I shouldn't start with a variable name with a number. Missing. Oh, yeah. Oh, we have a result, but we're getting it wrong. Let's see what the problem is. For AR slice 0 I. Oh, we should start 2. Oh shit. Oh, yeah, we should start 2. Okay, now we need to find 1 1 and target. Target is this. For let's see the log. 0 for 6. We need to find 6. So 0. This is for this 6 is 0. For 5, 0. 2 numbers, right? 2 numbers cannot 5. Okay. For 5, here, there is actually, but we get 0, so it's not right. There's a problem here. What's the problem? What's the problem? The end. The end. If end is smaller than 2. Oh, smaller than 1. Shit. I'm sorry. 2 is okay, actually. Still not right. If end is smaller than 1. Okay, result. We forgot. We get a div. Oh, why? We log it here. Console log. console log find result tuples for target and ARR slice 0 end +1. Let's see what happens. For 5, actually we have 1. Why don't we get the result? Okay, let's see. We start with 1. Current is ARI. 1. The target diff would be the diff would be target equals current, subtract with current. So we got 4. The current doesn't have 4. And then if has current, yeah, we increment it. Let's also log the occurrences. 1, 2. Circular 1. There's some problem here. Ah! Shit, there's a typo here. Great. Now I'll remove the log. Ugh. God. I think it should work. Great, but it's not very fast, right? Why?